Okay, now we want to find the antiderivative of this function. So we have the function to be the cotangent of square root of x divided by the square root of x. Okay, great. Okay, let's just start off by rewriting the function. So we notice that in the numerator we have the cotangent of something. Cotangent is known to be cosine over sine, right? So we're just going to replace it with cosine over sine of that same angle. So I will rewrite it as the cosine of the square root of x divided by, well, let me put this down first. Then we put it down as sine of the square root of x. And then we are doing that over the x variable. Okay, great. And now I can make a u sub. I can say let u be the sine of the square root of x alone, right? So say let u become sine of, let the square root of x. If that is the case, we need to get the du from there. So that means that du will become, well, if you differentiate, this is a function of a function, so we're going to make use of the chain rule. The derivative of this will give us the cosine of square root of x, and then we multiply that by the derivative of square root of x, which is just 1 over 2 root x. Okay, great. And then we put the dx over here. So from this substitution, this integral will become, let's just put the cosine of that in front, square root of x in front, right? And then we say divided by square root of x times the sine of that. Oh, take note, sine of this, all right, will now become u, because that's what we call it, all right? It's now going to be u. And then dx, well, we can make dx from the subject of formula from here by moving this over here and dividing by the cosine. So that means that dx will become, so yeah, you can notice that we're going to have it to be 2 root x times du divided by the cosine of the square root of x. Okay, great. So in place of dx, we are going to replace it with the whole of this. That will become 2 root x over the cosine of the square root of x times du over here. Okay, great. So as you can see, some things will cancel out nicely. The square root of x will go with this, all right? And then the cosine of the square root of x will also cancel out with that. And we're going to have this to become the integral of 2 over that. So we only have 2 over u left. Maybe I can push the 2 out front. So we're going to have 2 times the integral of 1 over u. And we are going to integrate that over the u variable. Okay, great. So as you know already that the antiderivative of 1 over u over u is going to give us ln of u. So just put it down here nicely, ln of u. And I'm using these absolute values to ensure that this thing exists for all values of u, given that u is sine of an angle, right? Okay, great. All right. So from here, we are not done yet, because we didn't start off with u. We started with x. So we need to get back to the original variable, and that will be, so if we replace u with what it was in terms of x, so you notice that u was sine of square root of x. So this can be written as sine of the square root of x, all right? And then we add an arbitrary constant to that. And this right here is the antiderivative of the function we were given earlier. All right. Thanks for watching. Please subscribe to my channel.